We will read covalent bonding today. Covalent bonding. Covalent bonding mainly takes place between two or more non-metal atoms. Covalent bonding mainly it takes place between two or more non-metal atoms. When two or more non-metal atoms share their outer shell electrons to complete their outer shell, then covalent bonds form. I repeat again, when two or more non-metal atoms share their electrons from their outer shell, covalent bonding forms. And there is strong electrostatic force of attraction present between the shared pair of electrons and the positive nuclei of both atoms. So what are the requirements to form covalent bonding that we read? Covalent bonding requirements are two or more non-metal atoms. What do? They share their outer shell electrons. They share their outer shell electrons. How do they share their outer shell electrons? They share outer shell electrons in a way to complete their outer shell full. To complete their outer shell full. So when we would say that outer shell is full, there are some elements that they have, if they have two electrons in their outer shell, then we say that the outer shell is full. And most of the elements, if they have 8 electrons in their outer shell, we say that the outer shell is full. For example, if hydrogen is in covalent bonding, hydrogen needs 2 electrons in its outer shell to make it full. And if it is such as sodium, magnesium, aluminum, they need to make 8 electrons in their outer shell to make it full. Actually, in sodium, magnesium, aluminum, this example is not good because we are actually studying covalent bonding. So better I say chlorine, fluorine, bromine, oxygen, these are non-metal atoms. So they have, if they gain 8 electrons in their outer shell, so their outer shell will be filled. We said that they gain full outer shell of electrons. So I repeat once again, some students join right now. The two or more non-metal atoms, when they share their outer shell electrons with each other, they share their outer shell electrons with each other to complete their outer shell full, then covalent bonds form. Then we call this bond, then we call this bond as covalent bond. And there is strong electrostatic force of attraction present between this shared pair of electrons and the nuclei of both atoms. There is strong electrostatic force of attraction present between these shared pair of electrons and both nuclei. Remember that when it is the nucleus of one atom, it is nucleus, singular form, and it is plural form is nuclei. Nuclei means more than one nucleus. All right. So these are just like theories. Please you mark it here. These are also written here. Now look at, I make it more easier for you. Look at this. For example, this is an atom. This is another atom. Both are non-metal atoms. So these electrons came from both atoms and they are sharing. Now this atom is thinking these twos are my electrons, and this atom is now thinking these twos are also my electrons. But actually these electrons came from this atom, and this electron came from this atom. But they are sharing in a way that this atom, left side atom, is thinking that these twos are now my electron, and this atom is thinking that these two electrons are now my electrons. So it is called sharing the electron pairs. Sharing the electron pair, both share their outer shell electrons and both become full outer shell, both obtain the configuration of full outer shell of electrons. I was talking about that there are some non-metal atoms. If they have two electrons in their outer shell, we say them that their outer shell is full. And there are some non-metal atoms. If they have 8 electrons in their outer shell, we say that their outer shell is full. There are which elements are like if they have only 2 electrons in the outer shell, we say full. For example, hydrogen. There are some elements they have. I can write it here. There are some non metal atoms which uh, there are some non-metal atoms if they have electrons, if they have 2 electrons in outer shell, we say that outer shell is full, such as hydrogen, okay, helium, lithium, beryllium, boron. Boron has 5 electrons, 2, 3. So not boron, carbon, not even carbon. Carbon needs 8 electrons to work. So only hydrogen is the example, and there are and most of the non-metal atoms, they must gain electrons to complete the outer shell, and there must be 8 electrons to complete the outer shell. Remaining non-atoms must have 8 electrons in their outer shell to make their outer shell full, such as oxygen, chlorine, nitrogen. They must have 8 electrons in their outer shell, and they want to make their outer shell full. Remember this, they want to make their outer shell full, and it helps to form covalent bonds. They want to make their outer shell full by making 8 electrons in their outer shell, by putting 8 electrons in their outer shell. Except hydrogen. Hydrogen just tries to keep 2 electrons in its outer shell. Now let's see how does it work. Here, look at this. Here, hydrogen, 2 hydrogen atoms. They come closer. That look at one electron is represented by dot. The dot is the electron of one hydrogen atom, and this cross is the electron of another hydrogen atom. And that's why this kind of diagram is called dot and cross diagram, because the electrons are represented by a dot and by a cross. Why by dot? And scientists, they thought that if we represent the electrons of different atoms differently by dot and cross, then we can understand which electron actually came from which atom. That is the thing. So dot and cross diagram, this is also called dot and cross diagram of hydrogen molecule. Look at this, they are sharing the electrons. Now this hydrogen, the left side hydrogen, is thinking that these 2 electrons are my electrons, so it has full outer shell. 2 electrons in its outer shell, so full. This hydrogen is also thinking that these 2 electrons are also my electrons, so this hydrogen is also happy, its outer shell is also full. So both are happy and both form the hydrogen molecule H2. So the formula of hydrogen molecule is H2, and the diagram, dot and cross diagram, is like this. This electron is from this hydrogen, and this cross electron you can say from this hydrogen. And hydrogen, that's why it is called diatomic. See here, there are two atoms. So hydrogen is say called diatomic. Hydrogen always stay as diatomic molecule. Won't you mark it? A diatomic molecule. And the atoms in an H2 molecule join together by covalent bond. And this covalent bond is very strong. It is difficult for us to break these covalent bonds. High energy required to overcome this force of attraction or covalent bond. Now, noble gases. What about the noble gases? Look at this. Noble gases. Noble gases generally they have full outer shell of electrons. They do not need to gain or lose electrons, and that's why they do not form covalent bonds. And everybody wants to gain the electron configuration like noble gases. All other elements want to obtain the electron configuration like as noble gases, and obtaining 8 electrons in outer shell is called octet rule. Remember, I repeat, obtaining 8 electrons in outer shell is called octet rule. And if any element gains electron or shared electrons with another element and gains 8 electrons in outer shell, such with its nearest noble gas, with as like its nearest noble gas, then that noble gas and that element is called that they have same electrons in their outer shell, and they are called isoelectronic. And then they are said isoelectronic. It is written here, isoelectronic. Let's see more examples so that we can understand. Look at this, hydrogen and chlorine. Normally, how many electrons an hydrogen atom has? Do you remember? Normally, a hydrogen atom has 1 electron in its outer shell. And how many electrons chlorine has in its outer shell? Chlorine. Do you remember? Chlorine has 2, 8, and 7 configuration. So a chlorine atom has 7 electrons in its outer shell. Chlorine needs 1 more electron in its outer shell to make it 8. To make 8 electrons in outer shell. Look at this. Chlorine needs 1 more electron here. Instead of 7, chlorine wants to make it 8. Because the nearest noble gas of chlorine is argon. It has 8 electrons in outer shell. So chlorine follows argon. And hydrogen follows helium. Helium is the nearest noble gas with hydrogen. And helium has 2 electrons in its outer shell. So hydrogen wants to make outer shell configuration such as helium, like as helium. So hydrogen wants to gain 1 more electron here. So what happens when hydrogen and chlorine, they come close together? They share their outer shell electron. Hydrogen says that think that my electron is also your electron. Then chlorine becomes happy, and chlorine also says hydrogen that you think that one of my electron is from now on your electron. Look at this. Now hydrogen is thinking that the electron, this dot electron of chlorine is also my electron. Chlorine said this. Chlorine is very good. So I also permitted chlorine to use my electron. So hydrogen now has 2 electrons. And look at chlorine. Now chlorine has 8 electrons in its outer shell, because now chlorine is thinking the cross electron of hydrogen is now its electron. So hydrogen becomes 2 configuration, outer shell is 2, and chlorine becomes 2, 8, 8 configuration. This is covalent bonding. So the bond is here, it is covalent bonding. Now this bond, the shared pair, this is called here a pair of electrons, right? A pair. Pair means 2 electrons, that's why a pair. But this is shared between hydrogen and chlorine. That's why this is called shared pair of electrons. And this shared pair of electrons have attraction from the hydrogen nucleus. Nucleus is positive, and from the chlorine nucleus. Chlorine nucleus is attracting this shared pair of electrons towards chlorine, and hydrogen nucleus is attracting this shared pair of electrons towards hydrogen. And this force of attraction is actually the covalent bond. This force of attraction between the positive nuclei and shared pair of electron is actually the covalent bond. Understand? Covalent bond. Now we look at this. It can be drawn like this also. No problem. Look at this. Now this two electron, the shared pair, it is expressed like this, covalent bond, simply like this. This is only for chlorine. Chlorine is diatomic. Chlorine is diatomic. Look at this, Cl2. Two chlorine atoms come together. They share their outer electrons. Both obtain the configuration 288. 288. It also gained the configuration of 288. Both are happy. Look at this. And if we want to show in writing style, it can be shown like this. So this bond is covalent bond. And there are some other examples given. Covalent bond in methane, ammonia, and water. This is the outer shell electron is shown here, carbon, nitrogen, electron configuration of nitrogen, electron configuration of oxygen. So I recommend you to practice methane, ammonia. Look at this ammonia. Nitrogen has 2 electron pairs free. Still, if you count, normally nitrogen has 2,5 electrons in its outer shell. These cross electrons are nitrogen's electrons. So if you count the crosses, you see that there are 5 crosses here. And 3 hydrogens come here and each share 1 electron with nitrogen. So nitrogen becomes full. Nitrogen has now 8 electrons in its outer shell. Because nitrogen here 5 plus 3. 3 electrons come from 3 hydrogens. So there are some other examples. This is water. It's very important. You must draw them and practice them. These dot and cross diagrams are important for your exam. So draw and practice them. This is ethane. This is the dot and cross diagram of ethane. Look at this. 2 carbons, 3 hydrogen with this carbon and 3 hydrogen with this carbon. It's a covalent bond. 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 Actually, covalent pair of electrons. Covalent pair of electrons. And what is the bond? Bond is actually these electrons and this carbon attraction and this attraction. So this is the covalent bond. 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 This is the covalent bond, right? And these are just the shared pair of electrons which are responsible to form these covalent bonds. Very important. Please write here, very important in your textbook. Oxygen, very important. Oxygen, look at this. 2 shared pair of electrons. Because it's necessary. 2 shared pairs. Electrons. Double shared pair is called double bond. Double bond because each oxygen has 2,6 electrons in its outer shell. So oxygen needs 2 electrons. So this oxygen gains 2 electrons from this oxygen, and this oxygen gains 2 electrons from this oxygen. So it's a double bond. It's a double pair. Look at this. It's a double pair. It's a nitrogen triple bond because nitrogen has the configuration like 2,5. Look at this. It needs 3 electrons in its outer shell. So when 2 nitrogen atoms come closer, this nitrogen gains 3 electrons from this nitrogen, and this nitrogen gains 3 electrons from this nitrogen. Look at the triple bond. It is called triple covalent bond. So nitrogen forms triple covalent bond. Triple bond found in nitrogen. Double bond found in oxygen. Double bond also found in carbon dioxide. Look at this. It's a double bond. It's a double bond. Look at this. double bonds. This is ethene, alkene. This is one of the hydrocarbon in alkene group. Hydrocarbon will be reading later, but now look at the dot and cross diagram. This is a double pair, double bond. The examples given in our textbook are all important, and then you must practice all of them which are drawn here. You must practice all of them which are given here. This is chloroethene, dot and cross diagram of chloroethene. Chloroethene. This is BF3, boron trifluoride. The name is boron trifluoride. It has a difference. What difference it has? Look at that. The boron atom has only 3 electrons in its outer shell, and it shared 3 electrons with fluorine. And the outer shell of boron, it is not 8 electrons. It is not full. Still, it forms covalent bonds. So this is a bit different one. Boron trifluoride. It is a bit different one. It is a different example. Boron's outer shell is not filled with 8 electrons, but still it forms covalent bond with fluorine. All right. Then look at this sulfur dioxide, another example of dot and cross diagram. Or sulfur 4 oxide is called sulfur dioxide, or it can be said sulfur 4 oxide, no problem. So this is all about the dot and cross diagram of covalent bonds, and this is called the central atom. Here sulfur is the central atom. And what would be the structure? If I draw sulfur, look at this, a double bond oxygen, and double bond oxygen. All right. What will be the BF3 here? B, here is 1. This is the bonding diagram. There is another fluorine. F for fluorine. F for fluorine. And the F is equal to, you can see this electron configuration. You know the electron configuration. Boron equals is 2, 3. And fluorine equals to 2, 7. All right. Each fluorine is full filled. 8 electrons. The fluorine atoms have 8 electrons in its outer shell, not the boron. So this is a different one. It's a different example. Still, it forms covalent bond. Now look at this. Here, hydrogen and chlorine. This one, the diagram is given here. I have nothing to show here. You know, chlorine, the electron configuration is 287, and electron configuration hydrogen is 1. So unnecessary to write. Carbon, the electron configuration, you want to see carbon is electron configuration 2, 4. Sorry, 2, 4. And hydrogen has 1 electron. So each carbon has, now look at this. If you count the outer shell electron, which are outer shell electron, you are understanding, right? These electrons of carbons are outer shell electrons. The electrons that I circled inside my ring, not these. These are inner shell electrons. So outer shell, the electrons which stay in outer shell are called outer shell electrons. You understand? I know that. The electrons which stay in outer shell called outer shell electrons. Okay. So the electrons which stay in outer shell are called outer shell electrons. Look at this. Here carbon is the central atom. All right. So if you practice all these, you will be efficient to draw them. The dot and Gauss diagrams are very important.